Section 2.1, using inductive reasoning. This picture, I love this picture. It's from the Tomatina, which is a giant annual tomato fight in Spain, and it just looks like a lot of fun, and it's fun to look at his face and see all the excitement and emotion that he's got on it. To start us out, we've got some vocab words. Firstly, a conjecture. A conjecture is an unproven statement based on observations. So, for example, you could make a conjecture about your grade in a particular class. If you study and do all your homework, then more than likely you're going to get a good grade. So it's kind of a prediction. So if you have studied a bunch, you can predict or make a conjecture that you're going to get a certain score. Inductive reasoning. Inductive reasoning is the process or finding of a pattern for specific cases, then writing a conjecture for the general case. For inductive reasoning, you can be finding a pattern and then use the pattern to predict or write a conjecture for how to find the next number. So we're going to do that now. Describe the pattern in the numbers and find the next three numbers. So example 1, we've got -1, -4, -16, -64. Think about what's happening between these numbers. For this particular pattern, we're multiplying by 4 each time. So that would be the description of the pattern. Again, we're multiplying by 4. To have the next three numbers, we're just going to multiply each of the consecutive numbers by 4. So the next numbers will be 256, then followed by 1024, and then lastly it's going to be 4096. Try the next one on your own. Pause your video at this time. Did you get that each number adds 1 1/2 or 1 5/10, and that the next numbers are 7, 8 5/10, and 10? If you did, give yourself a big giant smiley face. Example 3, make and test a conjecture about the sign of the product of any four negative numbers. So for this one, make a prediction and then test it with several different possibilities to see what the product of any four negative numbers will have for a sign. Pause your video at this point. Did you find that the product of any four negative numbers is always going to be positive? If so, nice job. Sometimes we have things called counterexamples. Counterexamples are specific cases which conjectures don't work, a specific case where it's false. Let's, for example 4, find a counterexample to show that this conjecture is false. Someone has described the value of x squared as always being greater than the value of x. But this isn't always going to be true. See if you can come up with a counterexample or a situation where the value of x squared is not greater than the value of x. Pause your video and come up with the answer. There's two situations that I can think of where the value of x squared is not greater than the value of x. For example, x is 0. If you square 0, it's 0, and x is 0, well, those two would be equivalent, not greater. Same thing with x equaling 1. 1 squared is 1, and so you're going to have equivalent values, not one being greater than the other. For your homework tonight, look at the below download piece of a PDF file. You're going to do worksheet 2.1, numbers 1 through 4, 7, 9, and 15 through 19. Skip the number line part on number 7 and 9 If you want to, you can print out the worksheet, but don't feel like you have to. It's fine just to bring in a paper copy of your answers to these problems. Bring this with you completed tomorrow and we'll discuss it in class.